Hello everyone and welcome to this particular video wherein we are going to discuss about the Kharash effect, also known as the Anti-Markownikovs rule or also called as the peroxide effect. Okay, so according to the Markownikovs rule, I am speaking about the Markownikovs rule over here. If we take this particular thing into consideration, that is an unsymmetrical alkene. Okay, so if I take over here unsymmetrical alkene into consideration, and if I react this one with hydrogen bromide, okay, so now when this particular reaction occurs, according to Markownikov's rule, it is going to be the CH3, CHBr, CH3. This is going to be major according to the Markownikov's rule, correct? Plus, what I am going to have over here is CH3, CH2, CH2 and Br, and this one is going to be minor product according to the Markownikovs rule. But in case if this same reaction is occurring under the presence of peroxides, okay, so if I am going to take over here peroxides such as benzoyl peroxide, so benzoyl peroxide C6H5CO twice O. Alright, so what we have taken over there is the benzoyl peroxide. Okay, so if we take into consideration of benzoyl peroxide, the entire reaction, whatever the products that you are going to get, is going to be changed. That means here you are going to get the first product, that is the 2-bromopropane as minor product in this case. Okay, as we have discussed in the previous video, saying that whenever the addition of an alkyl halide with an unsymmetrical alkene takes place, it all goes with respect to the reaction conditions. Now here the reaction condition is such a way that you are taking peroxide into consideration. So when we take peroxides into consideration, the entire product sequence, okay, that is going to be inverted. That means the one which we got there major, here it becomes as a minor. Okay, so now plus over here what we have is this particular product, and this is the 1-bromopropane. Okay, so the 1-bromopropane over here, this one will become as now as a major product. Alright, so in order to again understand why this particular thing has come as major and why this has come as a minor, we need to go through a mechanism. So here, the mechanism here is going to have 4 steps. In the previous case, in the previous video, we had 3 steps. Here it is going to be 4 steps. Okay, in the first case, it is going to be the generation of free radical. Okay, now the free radicals are generated right from the peroxides which we are going to use for the reactions. In this case, I am using the benzoyl peroxide. So let's take the benzoyl peroxide into consideration. C6H5C double bond O C double bond O C6H5. Okay, now this particular benzoyl peroxide undergoes a process which we call it as homolysis. Okay, so when it undergoes homolysis process, so what is going to happen? The particular bond is going to be broken here in such a way that both the oxygen is going to have 1 electrons each. So when they take up 1 electron each, okay, that means 1 electron will go here, 1 electron will go here. So when this particular condition is achieved, we are going to get over here C6H5CO, right? 2 dot. So this is how it is going to happen. So here we are going to have 2 of those molecules. Now this is highly unstable state. Okay, it becomes a highly unstable. Now due to which this again breaks down. It breaks down in such a way that carbon monoxide peroxide goes as stable molecule. So here we are going to look at the release of carbon dioxide. I'm extremely sorry, it is the carbon dioxide which is going to be released as a stable gas. Okay. Plus, what remains with us is 2C6H5, that is a phenyl free radical. Okay, so when we have the phenyl free radical over here, what is going to happen? This particular phenyl free radical is going to react with the hydrogen halides. Okay, so C6H5 is going to react with hydrogen bromide. So now again, one bond means 2 electrons. One electron goes to the hydrogen, one electron goes to the bromine. Again, homolysis. So that time, this hydrogen combines with the carbon in order to yield C6H6, benzene. Perfect. Okay, but now, as this particular hydrogen has taken one electron also goes with the bromine, right? So this is where the bond has cleaved. So therefore, we will get over here Br with a dot. So bromine free radical. So finally, we have got the bromine free radical here. Okay, so this is our free radical, what we were expecting, right? So this bromine free radical as what we have, it goes for the next reaction. That is the step number 2. Okay, so that is the attack of bromine free radical on the carbon-carbon double bond. Okay. So now this particular bromine free radical is going to react with the carbon-carbon double bonds. So now when the reaction occurs, let's take this CH3, CH double bond CH2. Alright, so let's take over here the bromine Br dot. Okay, now again, what will happen? 2 bonds refers to over here. Okay, so we are going to have 1, 2, 3, 4, 4 electrons, correct? Out of which only 1 pi electron is going to be involved. Okay, so these particular electrons, so 1 electron will be shifting to this first carbon, 1 electron will be shifting to the second carbon. So if you are going to attach this particular bromine here, the free radical will be generated on the carbon on the top, correct? So therefore, if this reaction occurs, let's say the carbon is going to attach to carbon number 1 or carbon number 2. Okay, so if this particular bromine attaches to carbon number 1, that means 1 electron will go to carbon number 2, correct? So that time I am going to have CH3, CH with a dot. Okay, single bond, CH2 with a bromine. Okay, so this is one possibility. Again, the particular process is homolysis even in this case. Now, what is the second possibility that we can have? The second possibility is that here you have added this particular bromine to carbon number 1, right? Here we are going to add it to carbon number 2. So if this bromine free radical goes to carbon number 2, then 1 electron will go to carbon number 1. Okay, so that time you will be having CH3, CHBr, CH2 free radical. Now, here again you have 2 different types of free radical. In the first case, it is a secondary free radical. Correct. In this second case, it is the primary free radical. So, again, secondary free radical. Right, and here what we have is the primary free radical. Okay, so now, which is more stable? Secondary free radical. So more stable, more is the rate of reactivity. More the rate of reactivity, that means more is the amount of the product that is going to be formed. Okay, so this is the sequence what we need to understand. So therefore, when we have this, it goes to the step number 3. So in the step number 3, okay, so what is going to happen here? That is CH3 CH dot CH2Br. Okay, so now it reacts again with another molecule of HBr. Okay, that time again homolysis occurs. As the homolysis occurs, what is going to happen? One electron comes to hydrogen, one electron goes to bromine. Okay, now this hydrogen attaches to this carbon. So when it happens, we have CH3 CH2 CH2Br. Finished, right? So this is a major product. Okay, so let's go with the next one. What we have is this. That is CH3 CHBr CH2 dot plus again HBr, right? So we are going to have over here is CH3 CHBr. Okay, so one hydrogen is going to attach over here, so I'm going to get over here, that is CH3. Okay, so this one is going to be the minor product over here. Okay, so how many steps do we have? We have 3. We need to discuss one last one, that is going to be the termination step. So the final step, and that is the step number 4, as what we have is the termination step. Okay, so in the termination step, observe this carefully. Here, after reacting, okay, you have taken into consideration of this hydrogen here, of this particular hydrogen here, right? What remains is Br and Br as the free radicals. Okay, so now in the termination step, the bromine free radical which was obtained from the previous step, these bromine free radicals will combine in order to give the bromine molecule. Okay, so this is how the Kharash effect or what you can call it as an Anti-Markownikovs rule, Anti-Markownikovs effect or the peroxide effect occurs. So the basic difference, if you observe carefully, is that in the Kharash effect or your Anti-Markownikovs effect or the peroxide effect, here it takes place with respect to the free radical mechanism, while in the previous case, and that is the Markownikovs rule. Okay, so whenever a particular process that occurs with respect to Markownikovs rule, it takes place with respect to a carbocation mechanism. Here it is taking place with respect to a free radical mechanism. So this is the difference as what we can say about the two effects. Okay, and so therefore it has a direct effect on its product, right? So we will see in the next video. Thank you for watching. Do take care.